Okay, ladies and gentlemen, today's lesson is moving straight ahead 4.2. We're approaching the end of our lessons on linear equations and how they work. And today's lesson is about finding the slope of a line. You'll find your lesson on pages 72 through 74, A through E. And the ACE problems are 2 through 15, 39, 43, and 45. And your learning target is that I can use the slope of a line to find the coefficient of an equation. Okay, so ladies and gentlemen, let's get started. All right, first, finding slope. Well, we need to know what slope is first. And this is what we're going to want to put down in our notes. That slope is an integer that represents the steepness of a line. And slope is defined as the rise, the change in y, over run the change in x. So what we're basically saying is we're making a fraction. How far is it going up or down? Over how much are we going right or left? And this can be a negative value or a positive value. If slope is positive, the line is going up. If slope is negative, the line is going down. Believe it or not, you've been using slope this whole time. We've just been calling it something else. You'll learn about that in a little bit. So let's go ahead and find slope. Here I have a line that is graphed on a coordinate plane. And I want to know, what is the rise and run? What is the slope going to be? Well, the slope of this, again, is a fraction composed of rise over run. Well, I ask myself, how much is this going up? Okay, it is going up 1, 2, so 2 up, and its run is 1 over. So I have a rise of 2, a run of 1, so I have a slope of 2 over 1. Now if I treat this like an actual fraction, the slope becomes 2. Okay? And this is a positive 2 because I am going upward on the coordinate plane. My values are getting larger and larger. They're not getting smaller and smaller. Okay? Now, how do we find slope with the table? Same thing. What is our change in y? What is our change in x? Well, in this case, x is changing by 1, right? Because I'm adding 1 each time to get my new answer. So my change in run is 1. What is, though, my change in rise, the y value? I'm going up by 4 each time. So I get a rise of 4, a run of 1, and that becomes a slope of 4 over 1, or 4, if we want to make it easier. Now, this is where things get familiar, because you might be saying to yourself, Mr. Briggs, if I'm multiplying y by 4, isn't slope just another way of thinking about a coefficient? To think I'm just multiplying x by 4, right? Well, you'd be right. And what we can do is we can recreate an equation very quickly by using slope. Here I have a line. Okay, I do not know what the equation is for this line. I just know that I have it. But I can find some facts out about it. I can find the rise and run. I know that the line is rising. Well, it's not really rising, it's going down by -4. I know that it is running, okay, it's going to the right by 3. So I get a slope of -4/3, which I can recreate as -4/3 x plus or minus the y-intercept. And the y-intercept is, well, where the heck is this line crossing my y-axis? Where do I start my line? And if I start my line here at positive 4. So all I do is recreate this equation as y equals negative 1 1/3, just reduced it down, x plus 4. And that's my equation. And I give you permission right now to pause this video and put this into a graphing calculator and see if you don't get something that looks an awful lot like this. You will. Probably. Okay. But now, let's go ahead and learn how to graph super fast using what we've learned about slope, because we can go the other way. I can use what I know about slope to graph a line really quickly. Let's try this first one. Y equals 1/3 x plus 2. Okay, well, what does this mean? Well, first, my y-intercept is plus 2. That means I'm going to start at plus 2, right? But then I need my slope. And what is slope again? It's rise over run. Without even needing a table, I know that I'm going to go up 1 over 3. And all I do is I go up 1 over 3, make a dot. Up 1 over 3, make a dot. And connect those lines up, and boom, you have yourself a line. I'm going to make a line that's not that thick, maybe. There we go. Yeah, it's not that straight either. But I have a line now that passes through those rules. Without having to make a table, without having to plot a whole bunch of points, I've graphed this line. Just for practice, let's graph the other one. Negative 1x plus 4. What does this mean? For this one, I'm going to use a different colored marker. I'll use a purple colored marker. It means I start at positive 4. So I make a line at positive 4, but this one has a negative 1 value. Well, what is negative 1? Well, negative 1 is negative 1 over 1, right? So that means I am going down 1 over 1. So I just repeat that pattern. Down 1 over 1, make a dot. Down 1 over 1, make a dot. Down 1 over 1, make a dot. And sure enough, if I put all that together, I get my next line without having to make a table. And again, if you don't believe me, go ahead and put this into a graphing calculator. See what happens. They work. They work every time. As long as you can clearly understand where the values are on a table or where the values are on a graph, you can find slope. And if you can find slope, you can graph it or you can solve it. You can do all kinds of crazy, neat stuff without having to do a whole lot of math once you understand the pattern. Okay, and the practice for finding this pattern is going to be on page 72 through 74, A through E, and your ACE problems 2 through 15, 39, 43, and 45. Have fun.